So good morning everyone, thank you for joining us. This is one of many sessions that we've run this week for World Green Building Week, and the theme this year is Act on Client. So Act on Climate. We've been running sessions all across the globe, across all of our different regions, and looking at what we can do to support this and how we can all make a difference. Just a little bit of housekeeping. You'll see at the bottom there's a question and answer box. If you can use that throughout the session, and we'll get towards the questions at the end. It should last for about 40-45 minutes, and then we'll answer those questions. If we run out of time to do the questions, then if you leave your details there, so just make sure that you put your name on there, then we can get back to you with a response via email. Once this session is completed, and once the rest of the sessions across the globe have completed too, we'll be putting all of these on YouTube, so you can revisit them or share them with your colleagues, or check up on any of the other regional ones that you might have missed. And without further ado, I'll pass over to Neil so we can get started.
Well, good morning everybody, and thank you Natalie, and it's great to have you all on the webinar today. Today is the 4th day of World Green Building Week, and we're delighted to be able to host this presentation. It's certainly on a very topical subject and one close to all of our hearts. We at Cundall are committed to achieving excellence in the field of low carbon design, having become both the first carbon neutral consultancy and first One Planet company, and our 950 staff in 25 global offices are all committed to providing excellent green solutions for our clients. And at that stage, Sophie, I should have said, if you show our locations and people. So this presentation is being carried out in Green Building Week in several of our locations, as Natalie said. And although in this new virtual world, we could have people from anywhere on the globe, and perhaps we do, this discussion today is primarily for the built environment community across Scotland. Next slide, Natalie, thank you. We need all disciplines to collaborate to address the climate emergency. And while Cundall offer multidisciplinary engineering consultancy, we achieve the best outcomes when we're working collaboratively with like-minded clients and developers and architects and quantity surveyors and PMs and agents and so on. Next slide, thank you. The climate emergency requires action across all sectors, and you can see here on the slide the sectors in which we operate most frequently. No sector is exempt from having to address their environmental footprint, and we are finding opportunities to do this in all of these sectors. Next slide, please. So I'm sure you're all aware of the climate emergency. In the recent BBC documentary on extinction, David Attenborough said that habitat reduction is perhaps the most urgent issue to address, but that most scientists agree that climate change is the greater long-term challenge. Next slide, please. And this is a telling slide. We're currently on a trajectory for at least 3 degrees global temperature rise, which is well above the targets and aspirations of the Paris Agreement. And this, of course, will have a profound impact on us all. And it's therefore vital that we act now and fast in a hope of alleviating the worst of the predicted outcomes. Next slide, please. And this will be familiar to you all, I'm sure. Over the past couple of years, we've seen the impact of climate change, and it's become more severe and widespread, and that ranges from the recent and sort of current forest and bushfires in America, previously in Australia, Southern Europe, and the flooding that we see regularly throughout our country. It's therefore vital, as I said, that we act, and really, in order to achieve a reduction on the scale required, we need a complete societal transformation to flatten these emission curves that we are seeing and allow our ecosystem to recover and cope. And achieving net zero carbon must be at the heart of our response to this. Next slide, please. So here's a little timeline. It's not a competition, of course, but what will make us change? And at the most basic level, government regulation will drive us to improve our game. Back in May 2019, the UK Parliament declared an emergency climate, and our own government set out legislation to become net zero by 2045. The UK government then followed suit in June, amending the Climate Change Act, committing the UK to net zero by 2050. And previously in the UK census, I'm sure a lot of you are aware, we'd only ever committed to 80% of that. Unfortunately, the very next month, the Committee on Climate Change reported that the UK was already falling well short of that 80% target. And of course, this implies that it's going to be very difficult to get to this 100% target that we've got between 2045 and 2050. Next slide, please. And the next driver for change, so if that's sort of national government, the next driver for change can be found in local authorities, and most major UK cities have now declared that they'll be carbon neutral well in advance of that 2050 target, and over 70% of the councils in the UK have declared a climate emergency. Part of the attraction to cities is that bold climate change action can deliver many benefits, such as better health and well-being, improved air quality, economic savings for individuals and businesses, new jobs, less congestion on our roads, cleaner and greener spaces, and so on. And in the middle of this chart, as you can see here, two of our very own cities, Glasgow and Edinburgh, and I'm sure it's not been a battle between them, but they both alighted on 2030. So that's an interesting slide. So next one, please. And finally, so we've gone from central government to local government, if you like, and then finally the drivers for change. And maybe in some cases this might be the most important one. The drivers are to be found in investors, developers and occupiers. And it's been good to see a whole swathe of these people sign up to various commitments and net zero carbon building commitment, and people like Argent and Granger and Jones Lang LaSalle and Lend-Lease, to mention but a few. So this is really good when it's also being driven through these type of folk. So having said all of that, I hope that's whet your appetite. We're now getting on to the really important part of the today's talk, the climate triage. And this obviously has a medical connotation, and Sophie will talk you through that. And to do that, I'd like to introduce you to Sophie. Sophie leads our Edinburgh office sustainability team. Sophie's passionate about delivering low carbon and zero carbon buildings, working with clients to achieve their targets in a commercial world, and all the time looking to give the best possible outcomes for the comfort and well-being of occupants. So I'm very pleased to pass over to Sophie, and she'll take you through the rest of this talk. Thank you very much.
Thank you, Neil, and thank you everyone for joining us today in World Green Building Week. So the operation of buildings, we know that's responsible for 28% of emissions across the globe, but this increases to near on 40% if we also include the emissions associated with materials and the construction of buildings. It's worth noting at this point that this means the embodied carbon associated with the construction project currently represents over a quarter of emissions from the built environment. So if you're not already looking to understand this, then it's likely that you will need to soon. It's therefore imperative that we start considering and developing scalable solutions to address this challenge. In recognition of the role the built environment has to play in tackling climate change, we're now starting to see a consensus among industry in terms of the level of action that needs to be taken. The World Green Building Council has set out their roadmap, and this outlines that by 2030, all new buildings must be net zero carbon in operation. Then by 2050, all new buildings must be whole life zero carbon, and all existing buildings need to be zero carbon in operation. Alongside this, the UKGBC have developed their framework, and this establishes two threads with associated definitions and principles. The first one, considered here in blue, represents net zero construction, and the second, in green, net zero operation. For the construction of new buildings, there is an expectation that these will be designed to also achieve zero carbon in operation, and this is indicated here by the D at the relevant stages. But in summary, we're essentially looking at first reducing construction impacts and optimising operational performance. Subsequent to that, increasing the renewable energy supply. Then after all this, we again review our resulting carbon balance and identify opportunities to offset. This is a whole different presentation, which I'm happy to expand on if anyone is interested, so just contact us about that. But our recommendation is that it's ultimately a last resort, or at least a short-term fix in any strategies towards zero carbon. Just to kind of give a bit of an understanding of carbon offset, if people aren't familiar with that, it essentially represents a fee that's paid to enable a reduction of emissions in carbon in order to compensate for emissions made elsewhere, i.e. on your particular project, for example. Offsets typically support projects that reduce the emission of greenhouse gases in the short or long term. And common project types include renewable energy such as wind farms, biomass or hydroelectric dams, but you can also invest in energy efficiency projects or the destruction of industrial pollutants or agriculture products, or for example, destruction of landfill methane or forestry projects. So the graphic on this slide is taken from the LETI design guidance, and if you haven't already, I strongly recommend reviewing this, as it's a really useful document, and our colleague Jen from the London sustainability team was involved in its development. So it essentially uses a top-down and bottom-up modelling method to determine valid performance targets that are feasible to achieve based on market available technologies. Despite this being a different approach to those being developed elsewhere, there is some reassurance that the findings from this exercise align with the recommendations from other key industry players such as the UK GPC, REBA and RICS. So the purpose of this figure is to demonstrate that to achieve net zero carbon status, the level of energy demand has to match the available energy generation sources. But currently, our demand far outweighs this. What we also need to appreciate is that there is also a limit as to how much renewable energy we can generate within the UK. So the priority is therefore to reduce demand requirements whilst also simultaneously increasing renewable energy generation until we can achieve that optimal balance, i.e. the situation on the right here. So this slide helps to reiterate some of these points, indicating how the building energy use associated with each sector needs to reduce over time, up to a point where this can be matched by the increasing availability of renewable energy, i.e. the point at which we achieve our net zero carbon economy. But we have a lot to do in terms of changing our mindset regarding how we have operated to date. Yes, we have been making inroads, but this has not been getting us nearly far enough. If we continue as we have, we'll get the same results, and I think that's maybe the definition of insanity. But we really need to be pushing further and harder in order to get to net zero carbon. Whilst this is a nice, easy graph, I appreciate it's not as simple as this in reality. So for example, there's the question of intermittency. And what we also have to consider is the introduction of additional demand requirements, such as introducing electric cars to the national grid. But we are provided here with opportunities as well. So for example, energy storage, how can this support us? We're therefore not necessarily looking at just this 2D graph, but we're also looking at moving into the direction of introducing smart technology and understanding the time dynamic that influences this as well. So other opportunities are that we can include consideration of sharing energy streams across a site. So for example, can we move heat generated in one area to another? So if we have offices that have a cooling requirement, then can we take the heat generated in those areas to heat the residential, or can overheating in classrooms be transferred to kind of heat a pool located on site? We need to start having a detailed understanding of the energy streams within our buildings so that we know and in terms of how it's going to operate as a reality, so that we can best optimize our strategies going forward. So if we consider operational energy, Howell Davies, Technical Director at SIBSI, said delivering zero carbon buildings is a huge challenge. LETI has taken a major step to help the industry work out how this is to be done. So we use LETI as an example here. They recommend an energy use intensity of 55 kilowatt hours per metre squared per year for offices. So that's that figure on the far right there. The graph highlights an assortment of measures that can be implemented to bring a building from its current benchmark, so 160 in this example, so its benchmark performance to a low energy design performance in alignment with zero carbon operation. Each step represents a recommendation based on materials and/or products currently available on the market. But it requires a considered understanding of how the building is intended to operate in order to best optimise the function it serves. But as I mentioned earlier, materials and construction represent over a quarter of emissions associated with the built environment. Where we now have a good understanding of the operational emissions and how we can improve that, it's a case of putting that into practice. What we now need to better understand is how the consequence of this in relation to embodied carbon. So in terms of the circles here, they're reducing as we go forward in times because the operational energy reductions becoming less. But what this means is that the upfront emissions associated with the construction, but also the ongoing maintenance in relation to the ongoing emissions, sorry, in relation to maintenance, repair, replacement works becomes more and more significant. So the lighter blue area becomes a bigger proportion of that circle. Fortunately, though, we do have the skills and the tools to at least help us start considering this, even if we're not quite yet taking the action necessary to address this, but we can get there. So we need to start understanding how the material choices and the construction techniques that we select are impacting on the environment. And so this is just providing a bit of an overview of all the factors that we are taking into consideration in relation to whole life embodied carbon targets. So for example, we're considering the extraction of raw materials, we're considering the energy associated with processing these, and then we are even considering the transportation of those materials from extraction to the processing plant and then on to site. So there's a lot of factors being included within this. In addition to this, we need to start considering, have we designed our buildings for disassembly? Are we using recycled goods? And can the goods that we do specify subsequently be recycled or reused at the end of life? So this graph here represents a breakdown of whole life embodied carbon performance for up to 46 example case studies. And this is broken down by, for example, substructure, superstructure, finishes, MEP, and so on until we get to demolition. At the moment, the case studies are averaging a whole life carbon target performance, of 1,030 kilograms of CO2 equivalent per metre squared. So this means very little unless we have a kind of understanding to put it into context for zero carbon and understanding of the scale of improvement that's necessary going forward. So for comparison, if we consider the Greater London Authority, they stipulate that new projects must be no more than 900 kilograms of CO2 per metre squared. If we then go on to consider the LETI guidance, then they're suggesting that the 2030 target is 600 kilograms of CO2 equivalent per metre squared for offices specifically. But then if we move forward to 2050, they're proposing a 350 target. So that is essentially a third of what the current average is for these case studies. And as you can see, that there's no examples getting quite there yet, though there's one at the far left which is getting close at least. So this slide is summarising a range of targets and assessment metrics that we are starting to see become more commonplace on the projects that we work on. And it's worth noting that while planning does have a role to play, it's not necessarily the key driver behind the attention that we're seeing in this area. And this kind of alludes to the point that Neil made in his introduction, that the organisations and the developers, for example, are seeking to have a greater understanding of their impact in order to take the necessary action to reduce their impact on the environment. And I'll touch on this a bit more later. So essentially, in order to achieve net zero carbon buildings, every aspect of energy consumption must be considered and minimised, the issue being what is that minimum. The best course of action is therefore to look at all the energy flows within a building and identify how they can be minimised. And within the context of existing buildings, we're seeking to do this without interrupting business continuity. Subsequent to this, the aim is to generate as much renewable energy on site, thereby creating our zero carbon enabled building essentially. So this is outlining Cundall's proposed 7 steps to net zero carbon. So starting with 1, passive design optimization, then further seeking to reduce operational energy demand by introducing optimized efficiencies and performance. Our 3rd step is elimination of fossil fuels where we can. And subsequent to that, providing on-site renewable energy and storage when it's possible, but also considering step 5, limiting upfront embodied carbon, and 6 is consider whole life carbon in conjunction with whole life costing. The final stage is 7, which is publicly disclosing performance annually using the RAP database, and it's that public disclosure that's kind of key to kind of encouraging movement on this in this area, and kind of holding everybody to account essentially. So further consideration at this point is that is that the point at which the building reaches zero carbon in operation is dependent on the rate of increase in the renewable energy content of the electric grid. So as that's introduced, then it will get easier going forward, but we still have to be doing these initial steps, which is the optimization and energy efficiency in order to get there. And so this brings us to our triage for the built environment. We recognise that we are currently in a climate emergency, but the effort to date has primarily been focused on new buildings. So what do we do about the existing stock? From what we've considered, I think we can understand that the need to design buildings that last is important. And we have done this to a certain extent if we consider what we have in our existing stock, and with an estimated 80% of the building stock in 2050 is already represented by existing buildings. But as much as 40% of this was constructed before 1985, when building regulations were first introduced, albeit in England, where the Building Act in Scotland was introduced in 2003. From the perspective of climate emergency, what we're considering is that the existing buildings, we're looking at those as our walking wounded. So what we need to understand is how bad is the problem? Which buildings require emergency attention if we are ever going to limit our global warming to 1.5 degrees Celsius? But then which are the ones that we can address through a care strategy applied over time? And finally, which buildings are essentially not going to be here in 2050 or don't have a place in our 2050 future? We need to ask if it's worthwhile continuing to act on these buildings, or do we need to focus our efforts on where we can make an impact? Now, I'm hesitant to suggest it's the end of the line for these buildings, but perhaps when I come back to discuss the embodied carbon aspects, then the reason for my hesitancy might become clearer. But ultimately, the main function of our triage approach is to identify the appropriate level of care based on the urgency of action required. So, where to start? We've identified, based on the relationship we've had with our clients, 3 key levels at which we're being asked to assess net zero carbon strategies. So we have this at a corporate level, where we're looking to reduce emissions across the whole organisation over a reporting year, taking into account day-to-day operations. So this essentially includes everything from, for example, how staff get to work, business travel, maybe where you're sourcing your paper, pens or coffee. But primarily focusing your attention on where you can make the biggest impact. And schemes that are available to help support this are, for example, science-based targets, where this is allowing organisations to demonstrate their efforts that they are putting in place to operate within the 1.5 degrees Celsius limit of global warming. At the other end of the scale, so the bottom bar here is the individual asset. So here we are considering the operational performance of the building as well as the associated embodied carbon. Whilst existing buildings may not have the upfront emissions from construction, we do still need to consider the embodied carbon associated with any maintenance, replacement, repair or even refurbishment strategy associated with those buildings. And what are the end of life implications? Can we disassemble? Can the materials be reused, recycled and so on? I've already touched on a number of frameworks and guidance setting targets for this. So for example, the LETI, UKGBC, REBA and RICS methodologies. So those are the ones that are set in those targets. But in between the corporate and asset level, we then have our portfolio level. And this is where we're looking to collate information relating to all building assets owned or operated by an organisation. So much effort today has been focused on the scope 1 and 2 emissions, but we really need to start considering our scope 3 emissions. And I'll go into more detail on this later. But to get an understanding of how important this is, then we have some estimates which are suggesting that this can represent from as much as 80 to 97% of an organisation's total emissions. So you can see the kind of scale of that these represent. Within this, what we are considering is the procurement of products and materials, but also services as well as any of the energy associated with processing materials, products, extracting raw materials, and so on, as I've mentioned before. So this makes it sound like a really complicated process, but it is doable. And the kind of key first step is understanding at a portfolio level is inherent to the overall strategy embedded within the organisation's operational procedures. So as I say, this first step is to essentially establish a boundary and understand what is encompassed within this. And this will be different depending on kind of what level we're operating at. So for example, if we're assessing this from a corporate level or organisational level, for example, we are including the actions relating to our staff behaviour and what they're doing and how that affects our overall emissions. But for example, if we're looking at a council level, then we might just be considering one aspect of their overall strategy relating to their building stock that they own or operate. What might be a new consideration in this overall process is the degree of supplier engagement, relating not just to products, but also considering the services that are being provided. So it's really reviewing that procurement strategy and having that ongoing engagement in order to improve the understanding of the carbon emissions associated with that. So to undertake this calculation, it's really important that a clear boundary is established, whether this may, for example, be based on what the organisation has financial control over, or do we consider it from an operational control perspective? And once we understand those boundaries, this allows us to establish the scale of the problem. So what is the extent of the total emissions calculated, and what are the key contributors? Now, this is really important as it helps us to understand where we can make that biggest impact. And it's about understanding the whole carbon footprint and what we can do to reduce this. So we don't want to just focus on, for example, a toe print. And the reason for this is that that kind of almost just leads to having a misdirection of focus. So for example, if you're standing in an airport and considering whether it's more environmentally friendly to use a hand dryer or a paper towel, then you've lost the focus on what the bigger problem is. So once we understand our footprint, and once we have implemented all efforts to reduce our carbon footprint, only then, and I emphasise that this is a last resort, might we start consider our offsetting strategies. So what are we including when we consider our scope 1, 2 and 3 emissions? So just to provide a bit of an overview, if you are, sorry, apologies if you are already familiar with this, but our scope 1 emissions are our direct emissions, so i.e. those that come from sources owned or controlled by the reporting company. So this represents any fuel combusted on site, so for example, gas boilers or oil boilers if you have those, but it's also considering refrigerant emissions. What are the maintenance strategies associated with this, or what do we need to consider at the repair and replacement opportunities? But these questions apply across all plant equipment and all building components. If we then have our scope 2 emissions, this is our indirect emissions. So those that are a consequence of the activities the reporting organisation, but that occur at sources owned or controlled by another entity. So for example, the utility company generating the electricity. So electricity is the immediately obvious example, but within this, what we are also including is any purchased heating, cooling or steam. As you can see, what we have done to date is relatively simple, but if we then go on to include scope 3 emissions, we start to get a little bit more complicated. So this here, we've got 15 additional categories introduced within scope 3, and this is all based on the Greenhouse Gas Protocol methodology. So this is divided into 8 upstream emissions, so that represents any emissions that you can influence through choice or selection, and 7 downstream emissions, which are represented of those that you based on services that you offer to others and the associated emissions with those. We never want to double count scope 1 or scope 2 emissions. So wherever they're categorised as those, they stay within that. However, there's a much more relaxed approach about scope 3. And the reason, so this might be double counted across different organisations, but that's accepted on the basis that the intention is to allocate the responsibility to anyone who has an ability to impact or influence the resulting emissions. So for example, if we have an organisation that leases out a building, then the electricity consumed by the tenant represents the tenant's scope 2 emissions. But these are the scope 1 emissions of the utility company generating that electricity. These will not be represented as scope 1 or 2 emissions by anyone else, but both these players have ability to reduce the emissions associated with these type of emissions. So for example, the tenant may modify their operational behaviour, or the power generator may increase the renewable energy content of the energy they generate. In terms of the building owner who's leasing out the building, then they also have an ability to influence resulting emissions based on the operational performance of their asset. So whilst it's accounted for as a scope 2 emission of the tenant, it's included here as a scope 3 for the building owner. So you see, it seems like it's double counted, but it's categorised within scope 3 because there's the ability to influence it, and therefore an attributed responsibility. So the strategy applied is unique to each project and client organisation, but we can apply some degree of simplification. So for example, if we are just considering a portfolio of assets, we can start to exclude some elements such as staff commuting, business travel from our calculations. And there may be more opportunities, but we have to review the calculations first to understand the extent or level of importance of our Scope 3 emissions. So if they're only having a marginal effect, then we're not wanting to invest time and effort in focusing what we're doing there. But what makes this approach really interesting going forward is that the operational end-of-life emissions feature here in the downstream categories. So what this means for portfolio managers is that they're going to place some value on the quality of the stock. So the operational performance of their building is included within their calculations, and so they have responsibility for the performance of that building, and again in relation to the end of life of that building. So that means that for the stock that they have, there's that encouragement to bring it up to standard, and they can't just dump poor performing assets because it's all included within the accountant. So ultimately, this on encouraging building owners to bring their products up to performance. So this then brings me to the RICS whole life carbon methodology, and this represents the industry recognised standard for this assessment, and our colleague Chan was integral to the development of this methodology. And you can see that it's comprised here of 17 phases, each taking into account emissions across the whole life cycle. And you can see that there's synergy with what we've already been discussing. So in relation to the kind of product stage, there's the materials transportation, manufacturing, the procurement, but then we also have the in-use operational energy in the red section there, and then we have this end of life consideration in terms of the deconstruction, disposal, and so on. So what we are trying to do within Cundall is essentially align those Scope 1, 2, 3 emissions, as we've discussed, relative to the greenhouse gas protocol methodology, and link that with the RICS methodology to provide clarity on how to calculate this and assess. And once we have an understanding, then and recognition of the scale of the problem, that's when we can start to kind of look at the recommended targets and essentially set strategies for our clients to facilitate the realisation of these. And we are seeing a greater use of tools to facilitate this. So for example, this slide here is referencing the performance relative to the neighbour scheme, which has had great success in Australia but is being rolled out within the UK. And this involves detailed modelling undertaken during the design stages, but which continues to follow up subsequent to completion of the building in order to review performance and check that it is operating as expected. This is having a massive impact. So, for example, in Australia, it's kind of helped to demonstrate the quality and effectiveness of the building design, and as a consequence, they're able to determine higher rental yields for neighbours rated properties. So this is being rolled out across the UK, and for example, we're using the design for performance assessment methodology to undertake detailed modelling to review the operational performance of buildings and identify that optimised strategy. So here you can see that the higher the energy consumption with the bar charts, then the poorer the rating indicated by the triangles, which drop down for the higher energy values. And as I've touched on, part of the challenge is identifying where we can make an impact. And so this slide touches on a really interesting project we've been doing with Newcastle Council to undertake a portfolio analysis. And essentially what we've taken is existing available data sources describing their building stock. So obtaining that from energy performance certificates or the display energy certificate databases, and using this analysis to strategically consider the building performance. So for example, this has allowed the easy identification of problem buildings. So essentially they're outliers. So in this instance, I'm taking that to mean buildings which are demonstrating a much higher energy consumption than is expected or typical for a building of that type. So for example, what this allows us to do is zone in really quickly on what buildings are demonstrating F and Gs as well. So what buildings are they going to have to take immediate action in order to improve the EPC rating? And through this quick identification, what we can start to understand are the contributing factors and identifying those, and then developing a strategy to reduce energy consumption. And a great benefit of this exercise is that, as I said, it's using existing available data. Therefore, this has allowed us to continue this exercise over lockdown essentially, and thus enabling Newcastle Council to continue to demonstrate progress with regards to efforts towards achieving emission reduction efforts. And so this brings us quite neatly to move on from understanding our portfolio performance to what we are doing for individual assets once we've identified the action necessary. And as I mentioned previously, Cundall have developed this 7-step strategy, so we've outlined this here. And we're using this to undertake a high-level review of the building asset, so identifying how its performance, how this compares to standard practice, and what level of action is necessary to get it to net zero carbon performance. So once we've understood the current performance, then we can start developing strategies in order to improve performance. The ultimate aim is to move forward, the ultimate aim is to move from current performance, here comprised of both fossil fuel and electrical energy consumption in the left bar chart, so that's the different shades of blue, and moving towards the recommended energy use intensity. So again, using that 55 kilowatt hours per metre squared value for offices in this instance. And so using our energy modelling to then assess the range of technologies that can be implemented, but also calibrating that against real energy data that we've taken from the kind of existing operational performance. And so what this allows us to do is reflect on the actual operational requirements as suits the need of the occupant for that particular building. And this is very much distinct from the modelling efforts for Section 6 of the building regulations, which are solely to test the performance relative to comparison, or to provide an easy comparison of buildings on a like-for-like basis. Therefore, the Section 6 does not reflect how they will be used in practice. So based on that calibrated model, we can start to identify appropriate and effective carbon reduction efforts and develop a route map to implement over the years to achieve the ultimate energy use intensity target. And it's worth noting that that energy use intensity target is the value even before renewables are considered, because the purpose of the renewables is to offset that 55 value. So for consideration of that route map over a number of years, this then allows us to develop a strategy that can take account of existing maintenance strategies, but also any kind of future planned replacement or refurbishment schedules. So that allows us to start to identify opportunities to implement efforts that tie in with scheduled works, or for example, the introduction of new leases, thus minimising the level of disruption associated with the process whilst maximising the potential benefits. So this slide here just kind of outlining from the experience that we've had on the projects to date, kind of quick wins and key considerations. So for our existing stock, we're looking at quick wins are like undertaking that air leakage test and remedial action, kind of looking at the continuous insulation layer, understanding external shading, incorporating LED lighting, our photocell absence detection controls to minimise lighting gains, understanding the kind of control strategy for our heating and cooling to avoid simultaneous responsive systems, turning stuff off out of hours. Like, it sounds obvious, but it's easily overlooked. Separate plant for out of hours usage, and insulating pipework and water heaters, or introducing new fans for air handling units. In terms of key considerations, then what we're looking at is optimising glazing performance, improving thermal performance, improving air tightness, introducing openable windows. So even if we are going to high airtight buildings, we still want to have that window opening strategy to mitigate overheating in the summer, and also be used as an opportunity to offset this mechanical strategy, so it's not being used 365 days of the year. And that enables us to adopt a mixed mode ventilation strategy. But further to this, then looking to phase out the use of fossil fuels as where we can, relax heating set points. So can we kind of encourage our occupants to kind of put on another jumper, or can we kind of encourage movement around the office so that they can sit at an area of the office that suits their temperature preferences, but also reducing internal heat gains. And a consequence of all of these is that then allows us to reduce our MEP equipment sizes, and also the additional benefit is reducing capital costs, and then also looking to maximise on-site renewables. So in terms of the services that we offer at Cundall, then as I say, we've got our corporate strategy and reporting. So that's where we're undertaking these carbon footprinting exercises or carbon neutral certification, working to consider supply chain charters or procurement strategies to help reduce the scope 3 emissions, carbon offsetting strategies, and developing climate change risk reporting. For our portfolio strategies and roadmaps, then it's development of those strategies and roadmaps and looking at those for existing assets as well. And then we have our usual services in relation to net zero carbon buildings, so developing those strategies, passive house certification, operational energy assessments, design for performance, which we really believe is going to have a massive uptake going forward, upfront embodied carbon assessments, and our whole life cycle assessment. And so this kind of ultimately brings us to the point that the cost of inaction is greater than the cost of action. So as I've said, it doesn't have to be a complex process. It can be incorporated within existing plans and strategies, and this will reap multiple benefits in terms of minimising the impact on the environment, but also improving the sustainability credentials of the associated organisation and improving the quality and value of that building stock. So therefore optimising its resilience relative to climate change, but also relative to dropping value. So that brings us to the end of the presentation. So again, this is just to let us know if you want the link to go to if you want to find out more, but otherwise please do feel free to get in touch with us beyond this presentation if there's any items in here you would like to discuss further.
Brilliant. Thank you so much, Sophie, for that. One of the questions we've had is, what's the biggest barrier? I know that you were talking about the benefits of implementing these strategies, but when we're actually looking at new projects, what is the biggest barrier that we're facing?
The biggest barrier, I think, one of the points I tried to make was that what we have been doing to date, it's just not been good enough. So we've kind of been making shifts towards more sustainable buildings, and we are making progress, but we're not getting nearly far enough. And that's demonstrated by the Climate Change Committee report saying that we weren't even on target for our 80%. So I think one of the first barriers is kind of encouraging that understanding that we really have to be changing our whole approach to this and kind of saying, considering sustainability from the outset and considering sustainability from kind of project concept and getting somebody on board at that concept stage to monitor what's being done throughout the project so that none of the kind of targets and performances are being lost. So it's understanding that we're really having to make a kind of seismic shift in how we are approaching this. But also I think one of the barriers that repeatedly come against is that people are using this compliance tool in order to assess performance. And the compliance tool is effective for its purpose, which is to demonstrate that the building has been designed in alignment with the building regulations, and it enables a comparison on a like-for-like basis, but it in no way represents how that building is going to operate in practice. So there's limitations to that methodology. And so we have to then think, right, can we incorporate this design for performance assessment, which allows us to understand the needs and requirements of that building and best optimize it? And then how can that allows us to then understand those individual energy streams and make a much better informed design decisions.
Thank you. And then in terms of, we've talked about when projects are dead and when we should kind of move on from them, but where do we draw the line when we're looking at heritage projects?
And the needs and requirements of the kind of individual buildings, and there is a strategy for all building types. So if we're looking at heritage, then part of the issue with those is the biggest kind of energy use with that is going to be your heat loss associated with those type of buildings. And we don't want to kind of disregard kind of we don't want to kind of just get rid of those buildings. We don't want to lose the heritage and historic buildings that we have. So how can we best develop a strategy for that? And so where heating is one of the biggest energy costs in those type of buildings, then that's maybe where we're looking at kind of strategies going forward, where it might be, if they're served by boilers just now, then it might be ensuring that those are hydrogen ready boilers so that they can connect to a future hydrogen system, which will be a much more environmentally considerate fuel source in the future.
Brilliant, thank you. As Sophie said, if anyone has got any more questions, please just get in touch with Sophie or me, and we can get an answer across to you. I'd just like to take this opportunity to say thank you to you, Sophie, fantastic presentation, and to you, Neil, for kicking us off this morning. As I mentioned at the start, this will go onto YouTube over the next couple of days. So if you've missed anything or would like to revisit it, then you can catch up on it there. I'd also like to mention that we are looking to start our series 3 of webinars. So if you've missed any of our previous series, you can catch up on them on YouTube. But series 3 will be coming shortly. And for the Edinburgh Scotland market, we are looking at a joint webinar with Fletcher Joseph on one of our recent projects, Kingstable Road. So keep an eye out for that in your inbox shortly. So thank you again for everyone for your time this morning. Sophie and Neil, thank you, and hopefully speak to you all soon.